Hello everybody, in this video I will show you how to save a WAV file from LT-SPICE simulation and also to visualize the FFT analysis of the signal. So I've built this simple circuit with a voltage source and a resistor and a ground, and the voltage source is sine waveform with DC offset 0, amplitude 10 volt, frequency 100 Hertz, and I ask to have 200 cycles to fill a simulation of 2-second time length. And actually, I set up here with this dot run, I set up here simulation, which is a transit analysis, stop time the simulation 2 seconds, as I told you before, and time to start 0 seconds. Okay, and then when I will start the simulation, I will have the transient analysis, and also the software will execute this directive here, which is basically the core of the saving the .wav file. So this is made of .wave directive, then the file path and the file name in this folder here with this name low.wav, 16 bits and 44.1 kilo samples. Which signal for the simulation? The node 001, VN001, which is this node here, as you can see on the left down corner of the software. So we run the simulation. We have the time simulation of 2 seconds. I can plot here my signal. I see here my 10 Hertz sine of plus 10 volt minus 10 volt. So this is my signal. And here I can see the FFT plot by right click, view, FFT, and again, FFT. It's not working. Yeah, now it's working. So I have here this plot in frequency, and I see my 100 Hertz tone with many harmonics. So we close this window, reduce this other one, and now we look in the folder, and actually we have a low.wav file. We run it, and this is our 100 Hertz tone. Now we can change the frequency of this voltage source, and for example we say that we want sine with 10 kilohertz frequency and still 10 volt. We want more cycles to fill the 2 seconds time simulation. Just say OK. Now we will say this with as a high.wav file. OK. We run the simulation. We plot the signal here. It's full because it's a higher frequency. We zoom in again, and we see the high frequency sine. We right click here, view FFT, same node. Now we have still a lot of harmonics to the simulation and the digital numerical approximation of the simulation, but basically our main peak is at 10 kilohertz. We can change the vertical axis and say that we want a linear axis, for example, and we'll see just this clear tone here at 10 kilohertz. Anyway, we shift back, we go back to decibel, logarithmic scale because it's the standard. So we close this, we close also this, and we look into the folder. Now we have also second file, which is high.wav, and the sound is of our 10 kilohertz sine. So we go back to the simulation, and now we do something a little bit different. We add the two sine that we have created. So we Ctrl C, we copy the voltage source, we connect all the pin and the resistor too, and we change the first source. We go back to our 10 Hertz and 200 cycles. Now we will change this to low high dot wav. We say OK. We run the simulation. We plot the signal in time. Now we have both frequency in our signal. We can see this with the zoom, the low frequency, and inside the high frequency. We can see this in FFT, and we will have both tones, 100 Hz peak, 10 kHz peaks, and harmonics here. We close this window, close this one, and we go back to the folder to see how this new waveform sound. We will have a mix of low frequency and high frequency here. Okay, so let's say that we want to clean this waveform, and we want to build a low pass filter to clean it. So we build a low pass filter with a resistor, this same resistor of 1 kilohertz, and then a capacitor here, which use the value of 1.6 microfarad, which gives us a cutoff frequency of 10 of 100 hertz. We close the circuit. We run again the simulation. No, now we do this. We copy this line and we say, let's save this node 1 as input. Node 1 is here, and save node 2 as output. Node 2 is here. So we run the simulation. We can plot the input in time, which is the same than before, and the output in time, which is the red line. We zoom in and we see the effect of the filter, which basically clean the signal from the high frequency and also add some phase shift. We can see this also in frequency with FFT. We select both traces. And now the input is the black one, which is the same than before, with the tone here, and also a lot of harmonics. And then we have the red trace, which is the filtered signal with the low pass filter transfer function, the peak at 100 Hz and the peak at 10 kHz. We close this window, we close also this time simulation, we go back to the folder, and we listen now to the input, which is the same as before. And we now listen to the output, which is the signal cleaned from the high frequency component, and so we have back our 100 Hertz frequency. Thank you for watching. I hope this could help.